Hello students. So today we'll study the third law of motion. Now, before going to this, we know that the second law of motion and first law of motion also we have studied. Just a minute. So third law of motion now we will study. Okay. So here, first you know that force is a push or pull acting on the object, resulting in its interaction with the another object, right? So force means push or pull, and force that is result of an interaction. So suppose I have one block here and I am applying force. I am applying force here. That means I am just interacting with this block. And force can be classified into two categories: contact force and non-contact force. So already we have discussed what is contact force. That means whenever you are applying one force by touching the object, that is the contact force, and you have a contact while you are applying the force. You have a contact with the object. So that is the contact force. And non-contact force, that is the gravitational force. Here you are not touching that thing, but whenever you are throwing the ball, it will fall down. So it will comes to the gravity. So that is the gravitational force. Also some magnetic force also we have discussed, electrostatic force also we have discussed as non-contact force. Now according to Newton, when two bodies interact, they exert force on each other. And these forces are known as action and reaction pairs, which will be explained in this third law of motion. Okay. So when two bodies interact, they exert force on each other. So that we will discuss here in the Newton's third law of motion. So here, the third law of motion, here you can see that this lady, she is walking. So whenever she is walking, she is applying one force that by her foot, and horizontal force exerted on the ground by person's foot, and horizontal force exerted on the person's foot by the ground, right? So she is giving one force to the ground, and ground also giving another force to the lady's foot. So here, and another thing you can see that this is the boat. Here, this is the boat. Whenever you are just going outside from the boat, you can see that some force you can feel that is in opposite direction. That means the boat that is moving in this way, whenever the person or the passenger he is moving in this way, right? So action that equal to reaction. And here you can see that in case of one person who is just pushing one wall or one object, at that time also there will be another reaction. Okay. So Newton's third law states that every action has an equal and opposite reaction. Equal and opposite reaction. So Newton's third law states that every action has an equal and opposite reaction. Action and reaction forces are equal, opposite, and acting on different bodies. Like this lady, whenever she is walking, that means she is giving some force towards the ground, and ground is also exerting some force on the foot of the lady. So here Newton's third law has been applied here. Now action has an equal and opposite reaction. Okay. Now third law, in the statement of the third law of motion, when one body exerts a force on the other body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. Okay. So the magnitude of the force are equal, and the direction of the force on the first object is opposite to the direction of the force on the second object. Suppose this is first object, this one is the second object. So if it will exert the force in this direction, then this will exert the force in this direction, in the opposite direction, right? And they will apply equal forces to each other. Now this is a hammer where you can see that, so the force of the hammer on the nail you are applying, and the force of the nail on the hammer also it will apply, right? So Newton's third law, if object A exert a force on object B, suppose here object B is the nail and object A, that is the hammer. So if object A exert a force on object B, then object B must exert a force of equal magnitude and opposite direction back on the object A. So this law signifies a particular symmetry in nature. Forces always occur in pairs. Okay. Here you can see that, suppose there is a bullet in your hand and you are just the gun will be here. This is the gun. Now the action is the accelerating the force of the bullet, and reaction is the recoil force on the ground. You can see that it will move just backward a little bit. So this is the recoil force of the gun. So that means action that equal to reaction here. Now here also, as I have told you using the lady, that whenever foot pushes down and back, then floor pushes up and forward. So this is the action and this one is the reaction. Another thing, this person, this is the passenger of this boat. Now you can see that whenever the destination will arrive and this person will move forward, or he will just step here, one step here, another step on the boat, and at that time you can see that boy's feet exert a force on the boat. If this exert a force on the boat, and as a reaction, boat exerts force on the feet. Okay. So Newton's third law of motion, we can say that if there are two objects, just a minute, I'm taking the pointer pen. So if you have one object A and B here, so the force whatever applied from point A to B, that is FAB, and this is the FAB, the force applied, and that equals to the body B to also, it will also apply the force towards A, and both are in opposite direction. Both are in opposite direction. Okay. So Newton's third law of motion is associated with the conservation of momentum. Here, if this will the force, then this is the FBA. So this, both the forces will be in opposite direction. Now this is the example. Propulsion of fish through the water is an example of the action-reaction pair. Here you know that a fish makes use of its fins. Okay, use of its fins to push the water backward. So here some water is there. Here some water is there. So with the use of fins, it will push the water backward. This push serves to accelerate the fish forward. So here the direction of the force on the water is opposite the direction of the force on the fish. So that's why the fish that will move forward. This is another example, that flight of the bird. Here you can see that these are the wings of the bird. Now wing pushes down on air with some force. Similarly, as a reaction, air pushes up on wing with an equal force. So the bird can fly upward, bird can move upward, right? So the flight of the bird is an example of the action-reaction pair. Action-reaction pair. The wings of the bird push the air downward. The air pushes the wings upward. Okay, the air pushes the wings upward. Now, suppose one swimmer is here. The same thing will happen. A swimmer pushes against the water. The swimmer's hand, whenever he is using his hand, he is exerting some force against the water, and water force of reaction against the swimmer also acting here. That's why a swimmer pushes against the water, while water pushes back on the swimmer, and the swimmer may move forward. This is another example. Lift is created by helicopters by pushing the air down, thereby creating upward reaction. Here, due to the upward thrust, you can see that the helicopter will move upward. This is another example. In case of tracking also, you can see this one. He is a climber who pulls down on rope, and rope pulls up on the climb. Okay, so the person can move upward. So few questions may come in this way. State Newton's third law of motion. So you have to say that it states that for every action there is an equal and opposite reaction. If they will ask you for the example in the next question, you may give the example of the swimmer, you may give the example of any person walking on the ground. So you can give so many examples. Now, what are the types of the force? Contact force, non-contact force. Example of non-contact force, gravitational force. Another thing you can write, just a minute. Another thing also you can write, that is the electrostatic force, electromagnetic force, magnetic force. So all these are examples. Next, according to third law of motion, to every action there is an equal and opposite reaction. This is a statement of the third law. Recoil of gun is an example of third law of motion. According to law of conservation of momentum, the total momentum of an isolated system is always conserved. Next question, a man is standing on a boat in still water. Fine. If he walks towards the shore, then the boat will, what happens? Just now I have explained with diagram that it will move away from the shore. It will move away from the shore. According to the third law of motion, action and reaction always act on the same body, always act on different bodies in opposite direction, have same magnitude and direction, act on either body and normal to each other. So here always it will act on different bodies in opposite direction, because we have seen that if we have a body A here, B here, then A will exert force on B, same force will be applied by the B towards A. That means the forces are acting on the different bodies, right? But in opposite direction. So that's why the correct answer is always act on different bodies in opposite direction. Now, let's solve this one. Okay. Two small glass spheres of masses 10 gram, 20 gram are moving in a straight line in the same direction with velocities of 3 meters per second and 2 meters per second respectively. They collide with each other, and after collision, glass sphere of mass 10 gram moves with a velocity of 2.5 meters per second. Find the velocity of the second ball after collision. Here, let's take the mass of two small glass spheres are there. So given data, let mass of one sphere M1 that equals to 10 gram. Let me change it into kg. So 0.01 kg, just 10 gram divided by 1000. So it will give you 0.01 kg. And mass of another sphere mass of another sphere, that is M2, that is 20 gram, let it be 0.02 kg, and the velocity, so first we are taking condition before collision. Okay, this is the first condition. Before collision, velocity of sphere having mass m1, that equals to u1, and this has been given to us 3 meter per second, and velocity of sphere m2, that equals to u2, that is given 2 meter per second. And after collision, let the velocity of sphere which has the mass m1, that is the u1 dash, it has been given 2.5 meter per second, and velocity of sphere m2 after collision, it is u2 dash, and we have to find out this factor. So we have to find out u2 dash equals to how much. Okay, u2 dash equals to how much. So let's do here. Now, momentum of the first sphere before collision, momentum that equals to m1 u1, this is before collision, so it will be our 0.01 into 3, that equals to 0.03, and momentum, let it momentum 1, momentum 2, that equals to m2 u2, remember both before the collision. So it will be 0.02 and our 2 meter per second, so it will be 0.04. Okay, now total momentum before collision, that equals to m1 u1 plus m2 u2, and this will be 0.07 kg meter per second. So now after collision, so after collision, momentum 1 dash, that is the m1 u1 dash, that will be 0.01 into 2.5, that equals to 0.025 kg meter per second, and momentum of the second body, that is the m2 u2 dash. Okay, so total momentum after collision, that equals to total momentum before collision. I repeat it again, total momentum according to the conservation of momentum, total momentum before collision, that equals to after collision. So we can write down according to the conservation of momentum m1 u1 plus m1 u1 plus m2 u2 that equals to m1 u1 dash plus m2 u2 dash. So if we substitute all the values, m1 u1 plus m2 u2 is how much? That is 0.07 kg per meter square, kg meter per second, sorry, kg meter per second. So here, if you put this value and m1 u1 dash, that is the 0.025 kg meter per second. So we can find out u2 dash that equals to 0.07 minus 0.025 divided by 0.02 that equals to 2.25 meter per second. Okay. So according to the conservation of momentum, before collision, what will be the total momentum? That equals to what will be the total momentum after collision. So using this conservation of momentum, we can find out the u2 dash. That is the velocity. That is the velocity of second ball after collision. So this is the answer. So this is the velocity of second ball after collision. Right? Thank you.